There we go. Okay. All right. So we have this. Now, now we're ready for an example. So we're going to see actually what's really nice is, even if we don't know what this angle theta is, we can still get the trig functions of it. We can easily do that once we know the length of all three sides. I think the reason that the Greeks actually came up with the trigonometry was buildings, like architecture. What does happen, as we'll see later, is if you know an angle in the right triangle, if you know one angle and a 90-degree angle, you know all three angles because the sum has to be 180 degrees. But if you know one side length and an angle, you can get the other side lengths using trigonometry. I mean, that will come up later, but let's do this one. Let's get the length of the hypotenuse. I can't say it. Let's get the length of the hypotenuse. Okay, well, that's just Pythagorean's theorem. Right? For C, we know that 3 squared plus 4 squared is C squared. Sorry, 1, 2, right? I'm basically giving you C. A and B are 3 and 4 respectively. We have C squared is A squared plus B squared. The unknown is good to put on the left side of the equation. But now we can easily get C. Right? We have C squared is equal to 9 plus 16, right? And this is, as we know, 25. So C squared is 25. We know the square. How do we get the number? We take the square root. So C is the square root of 25, which is just 5. So we know the length of the third side, the hypotenuse in this case. Now, without trying to figure out what theta is, let's get the trig function. And that's what I'm doing here. I put this here just to help remind us of the definitions. So for instance, the opposite side, 3 is OPP, right? That's the length of the side opposite 3. 4 is the length of the side adjacent to theta. That's ADJ. 5, of course, is the hypotenuse. So that's the length of the side opposite the 90-degree angle. So we have sine is opposite over opposite over hypotenuse, which is 3 over 5. Cosine, remember, it's SOHCAHTOA. Cosine is adjacent over hypotenuse, so that's 4 over 5. Tangent is opposite over adjacent. Opposite over adjacent, 3 over 4. Cosecant of theta, right? That's 1 over sine, right? So that's 1 over 3 over 5. As I said before, when you do 1 over, you invert it, you flip it. So we get 5/3. So 3/5, 1 over that is 5 over 3. Yeah? Anyone have a question? Have a question or? Guess not. Let me mute everyone. There we go. Okay. All right, so let me keep. Oh, almost done actually. Secant of theta is 1 over cosine, 1 over 4/5, as you can see. And again, that just becomes 5 over 4. Cotangent is 1 over tangent, which is 1 over 3/4, which is 4/3. Okay. And you could use sine over cosine if you wanted for tangent, and for cotangent, you can use cosine over sine. So, actually, I forgot to mention this in the reciprocal identities, but if you went back to that slide and looked, you can actually get, well, you can actually see, well, It turns out that all the trig functions you can get once you know sine and cosine. Once you know sine and cosine. Tangent you can get using sine and cosine. All right, so I think we're actually out of time. So let me stop recording.